So we're talking layout, anticipation of error in materials. A mirror in a bathroom provides a really nice example. This is the sort of thing, it's simple enough. We want to have a mirror on top of a backsplash where it sits, tight to the right wall and tight across the backsplash. In this case, we can add in some cutouts, still relatively simple. In terms of the measurements, we know that not every measurement is perfectly precise. We expect that they're accurate to within a 16th of an inch. And we also know that when we fabricate a mirror, it may not be exactly the size that it was intended to be. ASTM 1036 is the standard specification for flat glass. The allowable size tolerances in quarter-inch thick glass material mirrors are quarter-inch thick glass material. They happen to have a silver coating on them, but it's still quarter-inch glass material, and this standard is still going to apply. So we see the traditional designation of the thickness for quarter-inch glass, the range of acceptable thicknesses which qualify as quarter-inch thick glass. They range from 0.219 to 0.244 inches thick. Okay, a quarter inch is 0.250, right? So you can see the actual thickness of quarter-inch glass. It's not quite a quarter inch. The length and width tolerance, the cut size, so this is the size that we're ordering, okay? It's plus or minus 1.6, see the plus or minus, 1.6 millimeters or 1/16th of an inch, okay? A stock sheet, what we get in the crate, it's allowed to be plus or minus a quarter inch. But a cut size, we got to be within a 16th. Now something else you might find interesting, the squareness. So this is the diagonal measurement from corner to corner. You're allowed to have a cut size that is out of square, so not a rectangle, okay, and it can be out of square up to 5/64 of an inch. And this is what that looks like, 5/64 of an inch plus or minus on the edge of the glass, okay? And you can see in the case of our mirror, you don't know if that 5/64 is on the top side or if it's on the bottom side, okay? So it makes it a little difficult to fit nice and tight up against the wall and a vanity. So the actual size of the mirror can vary by a 16th of an inch in the width and the height dimensions. And then you look at the backsplash, maybe that's not straight, maybe that's not level. The wall, it's entirely possible that the wall is not level, especially when they put the drywall mud on it. It might not even be straight. When somebody requests that we cut a mirror and fabricate it so that it fits perfectly along the backsplash and perfectly along the wall. So I want to talk about how might we approach it. There's nothing above the mirror. It's not being cut to a ceiling, so we just need somebody to tell us what the height of the mirror should be. And then we have the width and the height, but we don't know, is this wall on the right hand side straight or is it curved? We don't know if the backsplash is level. So we could measure those things. If we want to make the mirror perfect, then we have to measure the wall perfectly. We have to measure the backsplash perfectly. And we have to measure the relative positions of the wall to the backsplash perfectly. This can become complicated rather quickly. When we're measuring this, we don't know what size the mirror is actually going to be made when it's cut. It's going to be made to whatever size we order it plus or minus a 1/16 of an inch. How do we put all of that together and approach something like this and do it in such a way that we know we're going to be successful? Well, a possible way of doing that is to measure the width of the backsplash, measure the height of the mirror, assume that the wall and the backsplash meet at 90 degrees, and everything is going to be fine. We'll just make a square mirror and put it in. And if it doesn't fit, then we can make another mirror. That's a rather expensive way to go about running a glass company, but many people have basically approached it that way, and we don't have to. There's a better way to do it. So one of the things we can take a look at is the dimensions of this space. Okay, so we'll pull this up. Now I have 60 inches for the width of the backsplash, 42 inches for the height of the mirror, and if you notice, I threw in a dimension here from the top corner to the outside corner. So because we have the dimensions of a triangle here, we are able to identify what that angle is at the wall. We could calculate the angle of this corner, um, and that's helpful. It doesn't tell us anything about is the backsplash straight or is the wall straight, but if they are perfectly straight and these dimensions are within a 1/16, then this mirror should fit in that space quite nicely. It's not really important to get across diagonal here because there's nothing bounding the mirror when we know we're going to have cutting error. So our 42 inches, it could be 41 and 15/16 or 42 and a 16th. Doesn't really matter. They both work, right? It's an acceptable size and nothing's affected. Now our 60-inch size, okay, if this particular customer wants the mirror to be touching the wall on the right hand side and they want it to end exactly where the cabinet ends on the left side, so now they want an exact width for the mirror. Okay, so they're saying they want this mirror to be exactly 60 inches. Well, in the glass business, the size of the mirror is plus or minus a 1/16 of an inch. It's the industry standard, and it's that way because there are errors when you measure out the 60 inches on the width to cut it to size. You could have some measurement error. When you score it and break it, the break might not go perfectly straight. You could have, some error in the fabrication of it. So if they want it to be from the left side to the right side in exact dimension, that's just not possible. That's not a job that we can agree to do because that's not how glass works. It's not how measurements work. The best that we could do is provide some type of a trim piece, J-channel or some other means of taking up that space at the perimeter of the mirror. That's the only thing that we can do. If they don't want that, then, we offer to get the mirror within 1/8 of an inch between the wall and the end of the backsplash. That's it. We can get within 1/8 of an inch. And the reason we can get within 1/8 of an inch is because we have a 1/16 in the measurement of the width, and then we have a 1/16 in the measurement and cutting of the mirror itself. So let's suppose that our measurement is 60 and it's actually 59 and 15/16, so we're a 1/16 short. And let's say that we cut it, we order it at 60 and they come in at 60 and a 16th. So our actual size is 59 and 15/16. We added a 16th when we measured, and then we added another 16th when we cut. That's an eighth of an inch, which is the accumulated tolerance from measuring and fabrication. An eighth of an inch is the very closest that we can be. Our diagonal dimension, it doesn't help. It doesn't, not only is it's gonna help us get this angle proper, so that the edge of the glass could parallel the wall and the backsplash. It doesn't make the actual finished size of this. It makes perfect sense. You measure from the left, you measure up, no problem. You measure up, you measure to the wall, no problem. Well, the simple fact is that the geometry between these two fabrications, it's on the wall, okay? And we want to reproduce that geometry in a fabricated mirror. What we want is we want a mirror that has the same geometry, the same relative locations of these cutouts in the mirror that we fabricate. We have to cut the mirror to size. And at the time we're measuring it, we don't know what the cut size of the mirror is because we don't even know what its dimensions are. Nobody's cut it yet. We need to take the dimensions from one single reference line. Like we have measured the height from the bottom, okay, and from the bottom. We want to measure from the right side of the mirror to the cutout, and from the right side of the mirror to the cutout. And when we measure from the left side of the cutout, okay, we have 30 inches from the right and 8 inches from the left. Well, this is simple enough, you might think, okay? Let's take a dimension here. We'll do some math, okay? And we have a 60-inch mirror, okay? From the left, we go over 8, and then we go over 2, and then from there, we could go over 50, and we're going to have, a real simple, easy solution. You do a little math, and you measure from the right side of the mirror when you fabricate it. Don't forget that our 60-inch dimension here, this is also a measurement, and it also contains error. You don't know how much error is in both of these measurements, but what you've done is you've taken two measurements which both could potentially be a 16th of an inch off, and you've used them to calculate a dimension. It could contain an eighth of an inch of error, not just a 16th, it could contain an eighth of an inch, because you're taking two measurements that both have error to come up with a third number. The third number has double the error. So you can't measure the left and measure the right and then do math and end up with a good dimension that you just go ahead and use like as if it's perfect. We always have to anticipate that there will be some error in our dimensions. I'll show you what this looks like. We have measurement error. Our cutout is 2 by 4. What we have is 2 and an eighth, okay? 2 and an eighth is 2 inches plus a 16th on both sides of it. So you get 2 and an eighth, okay? Because your measurement could be a 16th short. It could be 7 and 15/16, in which case, the width of the cutout, it ends up over here. Okay, it could be 8 and a 16th, and so in that case, then the cutout should be over here. So if we want to create a cutout that we know, and this is what we need to do, okay, in order for us to be successful installing a mirror in one trip, we have to create a cutout that is large enough to accommodate all possible positions or locations of this receptacle within the mirror. Okay, that means our cutout has to be bigger than the receptacle. It can't be exactly the same size as the receptacle, but it can't be, too loose that we can't cover the hole and the homeowner won't accept it, or whoever the customer won't accept it because the receptacle cover plate won't hide the hole. What we need is a size that's big enough to accommodate all of the positions that that receptacle can be in, so that we can install the mirror successfully without having to try and grind out the hole and, you know, really work hard to make this mirror fit in its intended location. So from the measurement that we get initially, the 8 inches and the 3 inches and the 2 and the 4, we know the location of it as it was measured, and then we know with the measurement error, okay, there's going to be a larger area around the measured cutout, and that larger area represents all of the possible positions of that cutout that fall within the maximum allowable measurement error. Okay, so then we look at this situation where we're going to cut the mirror. And when we cut the mirror, what we have is a shifting. Okay, if we cut the mirror a little too small, or too large rather, then it's going to shift this cutout to the left. And if we cut it a little too small, then it's going to shift the cutout to the right. Okay, that's just when it's being fabricated. It's going to be fabricated 8 inches from the left, and if the mirror is too big, then it gets fabricated a little to the left, and if it's too small, it gets fabricated a little to the right. So what happens here is we accumulate these errors. The original size of the mirror, okay, the original size, yeah, okay, we got the original size of the mirror, and then we accumulate this extra error. So you can see it's a little bit higher and a little bit lower. That's because our 3 inches is plus or minus a 16th, and then it's a little bit wider on the left and the right. That's because we have a 16th of measurement error, and we have a 16th of possible cutting size error in the width of the mirror. So our 2-inch wide measurement results in a 2¼ inch wide cutout width that's going to contain all possible positions of that receptacle. It'll be 2¼ on the width. Well, you say, how come it's 4⅛ on the height? We added a quarter to the width, but an eighth on the height. Why is that? Well, the reason for that is because we have two cutouts, okay? So we measure the width, we measure the height, we cut the mirror, all right? If the height is tall or short, it doesn't matter. It's not going up to a ceiling, right? It's just kind of floating in space. Doesn't really matter. The width, it's going to be plus or minus a 16th, right? We know we want it to be, you know, lining up with the end of the vanity, right? Okay, so it's going to do that. We don't know exactly what's going on at the wall. We know that it should be a little bit short of the wall because the drywall is most likely not going to be straight. We're probably going to allow an 1/8 of an inch there because we have a 16th error in the measured size and a 16th error in the width of the cut size. So a 16th plus a 16th is an 1/8. So you would want to make that mirror an 1/8 of an inch less than the wall. And of course, having that diagonal dimension will be very helpful to making sure that, you know, this edge of the mirror is parallel to the wall to the extent that the wall is straight. We know that this hole is a certain fixed dimension from the right side of the mirror, okay? So when we fabricate the mirror, let's assume that we measure and we cut this thing exactly where our measurements say that it should go. And what's going to happen, we're going to have an area around that 4-inch size where, you know, we have uncertainty in the measurement, okay? That's going to add a 16th all the way around. Adding a 16th on both sides, it makes it 4 1/8. over here, it's going to be big or little, plus or minus a 16th. Now, we could measure from the right over, we know where it goes. When we cut this, we don't know how big it is, and so our error is accumulating in this hole, right? It's increasing that by an extra plus or minus a 16th, so we ended up with 2 1/4. We could, in the reverse, we could say we're going to start here and cut this hole first, and it's going to be 8 inches, okay, the measured size plus or minus a 16th, right? So we could say that this hole is going to be 2 1/8 wide. If we do that, then we're going to measure from this side of the mirror, and again we have that plus minus, so our diameter would then need to be 4 1/4 to accommodate all possible positions of that cutout, the hole relative to the location of this cutout. It's a little bit tricky to understand that, I know, for somebody who is just looking at this from a standpoint of, I know I measured perfectly, why can't I just do math? The reality is, if you don't take this measurement, then you don't have a measurement there, right? And when you do math, you have this measurement, which is going to contain some amount of error. Okay, let's call it a 16th tops. And you have this measurement, which is also going to contain some amount of error. Call it a 16th tops. When you do the math, it's not obvious, but this number is going to have potentially 1/8 of an inch of error. And if you've ever installed, mirrors with cutouts, you know that you only have 1/8 of an inch really to work with. Now, if you're going to fabricate the mirror, and your fabrication locations are 1/8 of an inch off, this dimension contains 1/8 of an inch of error, then the fellow that lays it out on the mirror and does the fabrication, let's say that he's a 16th of an inch off. I mean, this is, the worst case, right? It's a 50-50 chance that this is going to be wrong. It's a 50-50 chance that this is also going to be wrong in the same way. So 25% of the time, this, both of those dimensions being wrong the same way, 25% of the time, 1 out of 4, they're going to accumulate so that both of them are too big and this is that much further off, or both of them are too small and this is that much further off because of it. Sometimes they're going to cancel each other out, but 1 out of 4 times we're giving the guy that's doing the fabrication, we're giving him a bad dimension, okay? And then half of the time, the fellow doing the fabrication, half of the time, he's going to be wrong in the same direction that this is wrong. So 1 out of 4 times we accumulate errors in the calculation of this, and 1 out of 8 times we accumulate fabrication errors on top of it, which is, probably in line with most people's experience that about 1 out of 6 to 1 out of 8 mirrors with 2 cutouts doesn't fit properly. You have to end up recutting it or trying to grind out the holes or doing something crazy to make it work. It's just simply because it's not being measured properly. And then we're doing math to figure out, where should that location be. And inadvertently, we're introducing error into the entire process. Anyway, I hope that this is helpful and useful. You want to think about measuring and layout with respect to reference lines, okay? You don't want to work off of different reference lines when you can work off of one reference line. And when you have conditions where you're going to be working with a very tight tolerance, you need to know what the material's fabrication tolerance is. okay? The measurements that you collect, um, you really need to anticipate, you know, how much error will there be in the width of this mirror? Can I promise somebody, oh yeah, we could have it touching this wall and we could have it ending exactly at the end of the backsplash? Well, who's going to cut that mirror? Maybe you're the most talented person in the world, but you're probably going to be scheduled for a different job and not have the opportunity to do the mirror fabrication. So you need to consider, how do we allow ourselves the space? You know, if we want to be exactly at the end here, we're going to have a gap at the wall here. It's going to have to be an eighth of an inch at least. You know, it's planning and anticipation, knowing what the tolerances are. These are the kinds of things that you have to understand when you go and measure something and lay things out. You have to anticipate, what are the tolerances? You know, how precisely can we measure when the mirror is cut from the side to the center line of where that location is going to be? You know, and then do the same thing from the bottom up. How precisely can we measure that when we're fabricating the mirror and locating that cutout? You know, what about this one? How precisely can we locate this? Um, I think if you approach your measurement collection and determination of the sizes of, you know, objects in that way, you're going to have significantly more success.